All right, let's begin. This is my second video. I want to talk to you about Thomas Kuhn and the excerpt from the Structure of Scientific Revolutions. A little background on Kuhn. Kuhn had a doctorate in physics from Harvard in 1949 and taught there until he moved to the University of California at Berkeley in 1956 and became a full professor in 1961, where he taught the history of science and the philosophy of science before publishing his book, The Structure of Scientific Revolutions, in 1962. The main thesis of the book is that science progresses by use of paradigms that guide the selection and interpretation of data until such a time that the field enters into a crisis, which can be caused by internal problems like persistent anomalies and failures of existing rules, as well as external problems like social and cultural reforms that essentially bring more attention to the essentially technical problems that are at the heart of the crisis. Such a notion about the nature of science doesn't seem very controversial to us, but at the time it described a very different view from the traditional notion of science as a process that moved slowly but inexorably in one direction with few exceptions, this notion of the progress of science. What was most controversial of Kuhn's claims in the book was the refutation of the possibility of science to describe nature in a true objective account. And I'd like to address this point at the end of this lecture. Let's consider some of the key points from the excerpt. The first major concept that must be understood as well as we can is the nature of what Kuhn means by paradigm. And this was also one of the most controversial problems, in that he didn't describe it explicitly and clearly and is a little bit ambiguous. But for Kuhn, the term is both an exemplar of procedures and rules and theories as it is the social practices of communities of scientists. In other words, in order to become a scientist, in the first place, a person must learn the existing body of theory and be taught the practices and rules that scientists in a particular field are using. This formal process is institutionalized in the form of classes, textbooks, professors like myself, colleges and laboratories and instruments. So when Kuhn is referring to the paradigm, he's actually referring to many different aspects of science and not only an exemplary model or an example of a procedure or a theory. Kuhn frames the reliance of science on the use of such complex phenomena as paradigms in order to reveal the different landscape of what he calls normal science versus revolutionary science, or paradigm shifts. The second main point is the term normal science, which according to Kuhn always relies upon the existing body of literature and procedures and focuses on problem solving within the well-defined limits of the field, so that the greatest efficiency in data collection and interpretation can solve the greatest number of problems most efficiently. Normal science is understood as tradition in this sense. Kuhn gives us a number of examples of traditional paradigms in various fields, like Newton's physics and the properties of light were understood as material particles transferred through an ether from the observer to the object and back again. And then that theory was overthrown, and it was thought that light was a kind of wave that reflected back from the surface of an object to the person's eyes. To our more modern notions, which is that there's actually perhaps a little bit of both going on in the nature of light, in terms of it exhibits both material and wave properties. Regardless, each set of the theories about the nature of light constituted a paradigm, which had to be overthrown for the successor to succeed. So Kuhn makes clear that scientific revolution requires a kind of destruction as well as invention to succeed. Think of the textbooks and the theories and the careers of professors and the adherents to the paradigm who must give up their previously held beliefs. It's a very destructive process. Prior to the 17th century and the development of scientific thought in the way we sort of understand it today, previous times had enormous amounts of competing theories in schools in virtually every field of scientific endeavor. Kuhn refers to this type of freewheeling speculation as pre-paradigmatic, a time which must necessarily disappear when the paradigm science period emerges. Once the paradigm emerges in a field, then the focus on data collection and interpretation creates its own inertia for development in order to create the results most efficiently. Only when the paradigm enters into a crisis can this paradigm be overthrown. Even in the instance of a scientific revolution, new theories must also address the main body of problems addressed by the previous theory, as well as solving the outstanding problems. Not necessarily all of the problems. Quite often a revolution results in the splintering of a field into smaller, more narrow, focused problem sets. Kuhn felt that his description of the way that science actually occurs in history described a process that is much like evolutionary processes. And this is what turns out to be the more controversial aspect of his thinking and description of the history of science. That the process is very much like evolution, where organisms are tested by nature and the fittest competitors survive and adapt to produce offspring. There's no ultimate goal that the organism is engaged in reaching, but rather a response to what is, not what ought to be or what might be. Kuhn's description of science is also this kind of process, one subject to adaptation and competition with the paradigm that survives, not necessarily the truest, but simply the most useful to the community or society at the time. In this manner, Kuhn describes Aristotle's physics as not false, but simply different examples of theory that people of different times and cultures use for describing and understanding the nature of the world. So if you've given some thought, if you'll give some thought to different scientific theories that you've studied, perhaps something from your major, and consider that they have a history of their own, perhaps this essay and Kuhn's ideas will change the way you think about the kind of science that's being conducted. Is there a revolution going on in your field? How would you take part in that? How would you defend the paradigm that's being overthrown? Why would you? What is important about defending scientific tradition? Can you think of some examples in our society in arguments about science or implications of scientific discoveries? I'd like to talk with you more in class about the relationship of this particular excerpt to our overall structure of our course, and consider its implications in some of the other kinds of readings that we're doing. So in between now and then, work on the discussion questions, and we'll work on coming up with some answers that are useful to us in class. Thanks.